So today we're going to pull back the curtain on the tech that gives AI a memory. The ability to understand context, to follow a conversation, to get that the order of things really, really matters. We're talking about recurrent neural networks, or RNNs for short, and they are the secret engine behind so much of the smart tech we use every single day.
Let's just start with the technology you and I use constantly. A lot of it feels like magic, doesn't it? But underneath all that, there's some seriously fascinating science at work.
Really think about it for a second. How does your phone know how to finish your sentences? Or how can a website instantly translate a whole paragraph into another language? How does a search engine know what you really mean, not just the keywords you typed in? This isn't just a bunch of clever programming. It's a very specific, very cool kind of intelligence. Okay, take machine translation. When it converts a sentence, it's not just swapping words one for one. It can't. It has to understand the grammar, the relationships between the words, to keep the actual meaning intact. That right there is context, and it is absolutely crucial.
Or what about search engines? When you type a question like this one, the engine isn't just looking for iPhone and Android. It understands your intent. It gets that you're looking for a comparison. It knows the sequence of the words is what gives your question its meaning. And then, of course, there are chatbots. For a conversation to feel even remotely natural, that bot has to remember what you just said a second ago. It needs a kind of short-term memory to keep the dialogue from falling apart. Now, all three of these examples, they all share one powerful secret.
And that secret, well, it's not magic at all. It's the ability to process data that comes in a specific order. In other words, a sequence. For these technologies, the crucial point, the whole game, is that order is everything.
Now, this is what the pros call sequence modeling. But really, you can just think of it as the challenge of predicting what comes next based on everything that came before. If I say, my cat is, you're expecting a totally different next word than if I say, my car is. That's sequence modeling in a nutshell.
And you know what's wild? Once you start looking for them, you realize sequences are literally everywhere. Text, obviously, is a sequence of words, but audio? That's just a sequence of sound waves. Video is a sequence of frames. Even the stock market is what we call a time series, just a sequence of numbers over time. Our world is just packed with ordered data.
And because sequences are so fundamental to, everything, the models that we've built to understand them have become, to put it simply, super powerful. They are unlocking things that were pure science fiction not that long ago. So what's the specific tool that was built for this job? Well, let's meet the hero of our story today, the Recurrent Neural Network, or RNN. This is the AI that was designed from the ground up to have a memory.
See, unlike other kinds of neural networks that just kind of look at all their inputs at once, RNNs are different. They are purpose-built to process information one step at a time, just like you and I do when we read a sentence or listen to a song. The real superpower of an RNN is something called a feedback loop. Think of it like this. At each step, as the network is processing one piece of data, it doesn't just produce an answer, it also passes a little piece of information, a memory of what it just saw, on to the very next step. Okay, so a feedback loop sounds cool, but what does that actually mean? Let's take a peek under the hood and see how an RNN actually remembers as it moves through a sentence. Let's just walk through a simple sentence. They are happy. First, the network takes in the word they. It does its thing, and it creates a sort of summary, a memory. It then passes that memory of they to the next step. Now it looks at the word are. But here's the key. It's not seeing are all by itself. It sees it with the context of they. It updates its memory with this new info and passes it all forward one more time. Finally, it gets to the word happy. But now it has the entire context of they are stored in its memory. This chain of context is what lets it understand the sentence as a whole. When you look at it this way, kind of unrolled like this, the core idea becomes super clear. Information from step 1 influences step 2, which then influences step 3. In an RNN, the past directly shapes how it understands the present. Now, this chain of memory isn't perfect. For really, really long sequences, that initial context can kind of get diluted and fade away over time. It's a famous challenge called the Vanishing gradient problem, and it's actually why even more advanced models were developed later on. So now we kind of get the mechanism, right? Let's connect this idea of memory back to those real-world applications we were talking about right at the start. So RNNs can be built in different ways depending on what you're trying to do. A many-to-one architecture reads a whole sequence, like our sentence, "they are happy," and then produces just a single output, like the sentiment positive. Simple enough, but for machine translation, you need a many-to-many architecture. It has to take in a sequence of words and produce a whole other sequence of words.
The big takeaway here is that the design isn't random at all. The structure of the network is carefully, purposefully chosen to match the problem you're trying to solve. Do you need one final answer, or do you need a whole new sentence? The architecture is built to fit the need. So RNNs were this fundamental, massive breakthrough. They gave machines a form of memory that lets them understand our world in a more sequential, almost human-like way. And that really just leaves us with a fascinating question. Now that they can remember, what will they learn to do next?